Hello, everyone, and welcome to the Climate Literacy in Practice session. This is it feels quite strange for me. I'm presenting, or I'm introducing from a different point in the in our office. So yeah, apologies if it's thrown you. It's certainly thrown me. Right, so I'm not going to moderate this session. I'm going to pass over to Duncan Baker-Brown, who is one of the UK's leading architects in this whole our transition towards a circular built environment. Now, Duncan is joined on the panel with Maria Smith from Bureau Happold, Scott McCauley from the Anthropocene School of Architecture, and Elmer Demisovic from 4D Architects, and also the founder of the Green Transferable Building Lab in the Netherlands. Now, as I say, I'm going to leave this session to the experts to host, but I think this is a really important topic that we have, because we're aware there's over 1,000 people, 1,000 firms in the UK signed up for the Architects Declare movement. There's 100 or so practices in the Netherlands who have committed to the BNR's, the Dutch Institute of Architecture's We Go Circular movement. There are campaigns such as the AJ's Retro First movement. There are all these initiatives that recognise that we as an industry need to be doing something about our about climate change, and recognising the importance that construction and the built environment, the important role it has to play in tackling this. But we really don't know what the answers are. I don't think anyone does. But part of that challenge is embedding these climate literacy conversations at every stage in our journey, in our projects, at every level of the business, the organisation that we're discussing, from part one architects right up to the most qualified and senior partners in the firm. These conversations need to be had. So that's what we're going to be talking about in this session. So as I say, I'm going to hand over to Duncan to moderate. Now, Duncan is a practicing architect. He's also on the RIBA Council. Duncan's also the principal investigator for 2 EU Interreg research projects into reuse of construction waste and building deconstruction and reconstruction. Duncan's then going to hand over to Scott. Now, Scott, as I say, is a qualified Part 2 architectural designer, and it was through his, I'm sure I won't sort of trample too much over what Scott's going to say, but it was through that kind of his own education experience, he realised that there was this huge gap in architectural education about that just completely disregarded or didn't include anything to do with climate literacy and the climate emergency that we're in. And so he founded the Anthropocene School of Architecture, and he will tell us more about that and what he's doing with that as we go on. We then have Maria Smith from Bureau Happold. Now, Maria is a Director of Sustainability and Physics at Bureau Happold. She's an award-winning architect and engineer. And she is works within the discipline works within multiple disciplines to bring the built environment in line with the planetary limits. She's also a counsellor on the RIBA, a trustee of the Architecture Foundation, and she's on the steering committee of Architects Declare. And lastly, but certainly not leastly, is Elmer Demisovic. Now, Elmer was the head of the BAM, the Buildings as Materials Bank Research Group for Reversible Buildings, and as I mentioned, is the founder of the Centre for Green Transformable Buildings. Now, an expert panel with lots of incredible insight and value to add to the conversation. Duncan, I'll hand over to you to kick off and to moderate the session. I'll be in the audience keeping an eye on the chat, so hopefully I'll be able to facilitate from there. But without further ado, I think I'll pass over to you, Duncan. Oh, you're on mute still, Duncan.
Yeah, thank you, Fraser. I'll just briefly set the scene in terms of who's going to speak about what. Scott, for the last 18 months to 2 years, has been doing a lot of workshops around climate literacy with practices as well as schools of architecture. So Scott's going to set the scene around this whole topic, actually, and then we'll lead into a talk with Maria, who's going to look at a couple of topics: the relationship between current and emerging economic systems and the natural environment, and also looking beyond carbon. A lot of us are preoccupied with the carbon figures, the carbon crunching, but it's a lot more than that, actually. And then we'll end with Elmer, who is obviously a practicing architect and a scientist, and she's going to look at lots of case studies that actually sort of test these ideas around closed loop systems and working in harmony with planet Earth. So I'd like to hand over to Scott now. Over to you, Scott.
Okay. Thank you very much, Duncan. I'll just get the screen share set up. And yeah, so just to kind of kick things off, I'm going to really broadly set the scene in terms of climate literacy of the built environment and kind of what I've been doing with like students of architecture and practitioners as well. So like Duncan Fraser mentioned, I founded the Anthropocene Architecture School because the education I got really did not set me up to get engaged in the climate conversation. It wasn't in project briefs, it wasn't in lectures, and I had to go outside of architecture school to go and actually find these opportunities myself to get stuck in. So what the Anthropocene Architecture School is and has been doing, it's an agile school of architecture, activism and climate literacy that started in Glasgow. So through this, as an armature, I support built environment professionals, students and their educators in responding to the climate and ecological emergency. And since its launch at 2019's Architecture Fringe in Scotland, it's delivered over 30 workshops internationally, including being invited to actually educate the educators at schools of architecture, including the Macintosh School of Architecture in Glasgow. So places this has taken part in have been very different. It's been all online for the past 6 months, but before then, it's been in the oldest Victorian music hall in the world during the Architecture Fringe. It's been during the Edinburgh Fringe. We did workshops with Extinction Rebellion, NGOs, activists and architects and the public alike. Then it's been in architect offices. It's been in conference halls, ridiculously, and just in lots of other places that I'll jump through as well. So climate literacy as a very broad thing, as I'd kind of define it myself, would be understanding the kind of the climate and ecological emergency is not just to do with carbon. It's that really broad context of climate and ecological emergency, and it's this climate crisis. So it's all of the overlapping intergenerational injustice, it's the climate injustice, it's to do with the mass extinction of life, the biodiversity crisis. It's incredibly broad. So just to give everyone a really fast crash course, we've had evidence of climate change every single day in the weather since 2012. So that means it's no longer just an anomaly, a one-off, and every once in a while, it's a consistent background accompaniment to everything we do and design. So just to give everyone one slide of the past 18 months in kind of climate shocks and disasters, we've had everything from temperatures of over 22 degrees above the average in Greenland. We've had 45 degrees in the Arctic Circle on some occasions. And then even just a couple months ago, and well, last month, we had the Californian wildfires, which have been exponentially worse than previous years. So this graph here will just really concisely show that as we've had this kind of overlapping information, if once we pass that threshold of safety that scientists gave us of 350 parts per million, the planet's temperature has started to rise quite a lot. So we're between a 1.1 to 1.2-ish, dependent on data set, temperature rise already. So with that kind of 1.5 degree threshold that the IPCC laid out in the October of 2018, we were told that the difference in impacts between 1.5 and 2 degrees of temperature rise were exponentially worse. But quite shockingly, this didn't come into my architectural education, and it wasn't really spoken about in practice a great deal. The conversation has very thankfully moved along, thanks to people like Maria and Duncan kicking it, but it's kind of taken a while to catch up. So we've got things like this, these different pathways, and to achieving them does involve the built environment to an incredible degree. So if we don't, but business as usual is going to lead to at least 3 to 4 degrees of temperature rise. And seeing what's already happening at below 1.5, that's going to be an exponentially amount worse. So the IPCC report actually really specified what we need to do in construction. So all pathways that are consistent with a below 1.5 degree temperature rise require that all building emissions be reduced to at least 80 to 90% by 2050. So that's the least we need to do. And construction needs to be fossil fuel free and near zero energy by 2020. So that's right now. And there's an need for an increased rate of energy refurbishment to at least 5% per annum as well. So we've been given the numbers. The IPCC has laid them out. So the really important thing to remember is that 39% of all the carbon emissions in the world at the moment are related to construction. So 28% of them are operational energy and 11% are embodied carbon. So everyone involved in architecture, design, construction has the ability to impact and reduce that 39% number. So other numbers to always remember around this are that 85% of buildings that shall be in use in 2050 are standing up right now. and it saves about 55 to 75% of carbon emissions to retrofit a building instead of just demolishing it. So that's just kind of some baseline figures as well. But just on the topic of circularity as well, according to the most recent kind of circularity gap, the planet's economy is only 8.6% circular. So we've got this huge kind of massive gap to start addressing. So it's great where we are, but hopefully as this conversation becomes more kind of mainstreamed into education and construction, that can be catalyzed to be a hell of a lot faster. So another really important part to notice about the relationship between construction and the IPCC report is that we were given a planetary budget for a 67% chance of staying below 1.5 degrees of warming, and that was 420 gigatons in 2018. So very importantly, we emit at the moment between 52 to 55 gigatons every single year. So unless we reduce those incredibly fast, we're going to overshoot that within 8 years. So this graphic by Letty really beautifully illustrates all the points in a building's construction, use, maintenance, deconstruction, where carbon's emitted, because our typical life cycle, the long lifespan is traditionally been seen as about 65 years, which in the case of a climate emergency is far too short for buildings to be doing. We need to push that as far as possible, have a capacity for transforming buildings and changing their use and not simply knocking them down when their use goes away. So the next bit of information is more about that kind of injustice and looking at where we are in terms of the planetary conversation. So if you look at the numbers, the global north is responsible for 92% of historical emissions. So that's 92% for global north, and the global south, who proportionally have the majority of the impacts, are only responsible for 8%. So this was published last month in The Lancet. And when you start to look at the kind of emissions by world population as well, even though it's not all about carbon, but just to kind of look at some numbers, the richest 10% of people on the planet are responsible for 49% of total lifestyle consumption emissions, and the poorest 50% are responsible for less than half, well, less than 10%. And again, 100 companies are responsible for 70% of all the greenhouse gas emissions since the 1980s. So it's no longer down to a personal, very small scale change, it's systemic in its entirety. And then just to look at, after remembering that figure, the global south has only been responsible for 8% of historic emissions. And this graphic here shows where in the world are facing the most risks and are most vulnerable to climate shocks as well. And as Naomi Klein summed up really concisely in her last book, for the past 3 decades, so since the IPCC was created, so since the first report was published 30 years ago yesterday, the refusal to lower emissions has been accompanied with a full awareness of the dangers. And this kind of recklessness would only be impossible without institutional racism, even if that's only latent. So we now know the economic arguments as well. So since 2016, we've known that climate change could have been curbed by about 21% of global GDP, but to leave it unchecked would be about 20% of the then damage. And the recent report that came out this month was that it would cost 0.5% of global GDP to reach net zero by 2050. So the numbers are actually, we know what they are. We know what we're working with. So one huge problem is public awareness on what net zero means, what it means to get there, what has to change. So a recent study in the UK showed that 64% of people surveyed had never heard of net zero before. So in construction, we've got this huge part to play in the conversation of making that public knowledge. Then when you're speaking to practices about this, so how do you embed climate literacy in practice? So this is a lot about having conversations about what your practice is capable of delivering, what skill sets are missing, actually letting people talk about how they feel about climate change as a whole and creating spaces to do that. So quite a few of the workshops I've done have been an hour of teaching and maybe half an hour to hour and a half of just actually talking about what needs to be done and what each practice in themselves can do. So when I looked at architectural education and to see where the gaps were, so I did some research a year ago to kind of pick out where in your typical degree, where the gaps are missing. So the total student understanding of sustainability and their own self-assessment was a very optimistic 59.4%. And just on the right-hand side, that will break down where it is. So it's looking at kind of adaptive reuse, ecology, and things like that as well. So, but at the same time, this means recognizing that practitioners coming into the profession are going to be feeling the kind of mental and emotional side of climate change as much or more than you're feeling it yourself. So in workshops now, I've now taken to giving people the space to share this, as this is something we've not been doing before. So in workshops I've done with landscape architects, I asked a room of 100 people who'd ever spoken about how they felt about climate change, and we got 6 hands very tentatively raised out of 100. So that's something we can start to do in enabling that conversation to take place. And just to really hammer that point home one more time, so 39% of all the carbon emissions on the planet are to do with construction. So we've got this huge potential space to do incredibly good things in. So if we can embed climate literacy into our conversations and how we speak and how we engage with our clients and institutions, we can try and affect a bit more of a kind of cultural shift in that direction. So I'll just kind of wrap up around there because I think I've almost hit my time limit. So one of my favorite quotes of all time is that the role of the artist is to make the revolution irresistible. So architects are not entirely artists, but our role is kind of illustrating what the future could look like. So I'm going to kind of leave on the pitch that the role of the architect is now to make decarbonisation inevitable. So to paint a kind of picture of the future and that makes this something people really, really want and is entirely irresistible as well. And I'll wrap up before I hit my time limit as well. So I think I'm done.
Thank you, Scott. What a pro on the button, actually. Wow, it's always a bit of a roller coaster watching you speak because yeah, you do it so well and clear. I've got 15 questions, but they're going to wait because I want to introduce Maria Smith, Head of Sustainability at Bureau Happold. Over to you, Maria.
Hello. Okay, I'm going to share my screen. Where's it gone? Anyway, hello. Thank you, everybody, and thanks, Duncan, for having me for this conversation. So in 15 to 20 minutes, I'm going to cover all of the world's biggest problems. So let's get stuck in. So as Scott has already mentioned, this is about much more than just carbon. However, I think it's really important to understand what has happened in terms of the public awareness and the kind of the crisis and emergency around carbon over the last couple of years can teach us. Because what we saw in that October 2018 IPCC report that was so shocking and so kind of incisive, and this incredible moment of that sort of unearthed this incredible awareness around what we really needed to do. The thing is that the reasons behind that and the problem behind the lack of action until then was that we were largely relying on and hoping that carbon capture and sequestration technologies were going to come forward, and they were going to come forward at such a scale that we would be able to continue to kind of keep emitting more and more, and then be able to kind of curb our emissions much more slowly because this technology would help to bridge that gap. And then over the sort of 20 odd years between the late 90s and the 2018 report, over which especially technologies like BECCS were being explored in more detail, it became clear that dream, that hope, wasn't going to come forward at anywhere near the scale and speed that we had previously expected it to. So then suddenly we had to remodel everything without that kind of level of capture and sequestration, and actually look really hard at the kind of cuts that we needed to make. And one of the key reasons that we didn't sort of make that decision earlier, and the reason that we were so seduced by carbon capture technologies, is that we were looking at sort of, I'm talking about sort of we, big collective we here. We were looking at the kind of the relationship and the close correlation between material footprint and carbon dioxide emissions with global GDP. And we were very scared that if we try to make sudden cuts to carbon dioxide emissions, that's going to have a huge economic impact. And there's always this trade-off being talked about, and we hear it pretty much, every second sentence at the moment in terms of dealing with COVID, for example, but the economy mustn't be, harmed in any way, and that the close relationship between carbon dioxide emissions and the economy meant that we were sort of ready to believe that, yes, this technology can help us kind of maintain the economic status quo. And, the fact that we were so allured by that technology has now put us in dire straits. And I'm sure everybody's already seen this graph, but it's just bears repeating to sort of look at, if we'd have started sooner, how much more gentle the transition could have been. And I say this not to depress us all, but just to remember that we need to be looking ahead, and we need to not make the same mistake as we made with carbon with biodiversity collapse. this is this cartoon that's kind of been doing the rounds a lot now. And yes, we're looking at the COVID-19 pandemic right now. And yes, we're looking at a recession. And behind that comes climate change. And behind that comes biodiversity collapse. And I'll talk more in a minute about whether or not it's really right to frame these as these successive crises that are coming for us. But my point really here is that, like, what we've seen since 2018, we have to not forget how different the climate, the environment was for speaking about carbon only 3 years ago to what it is now, and why that sudden change has happened. And that if we're not careful, we're going to have that same conversation around biodiversity collapse. So while I absolutely, I'm so pleased that the awareness and projects like Scott's are really changing the kind of the level of literacy around carbon and so on at the moment, and not just carbon, that we have to talk about biodiversity and ecosystems as well, because they are critical and they're in critical condition. We are deeply, deeply reliant on ecosystem services, which is a horrible way to put it, but at least it sort of says something from that kind of human-centric point of view. But, the reality is that we living in a very, very networked ecosystem, and human health is absolutely bound up in all of these other systems being successful and working and so on. And we don't even, really fully understand the way that, if we fiddle with something over there, how it's going to affect these systems. So it's really, really important that we appreciate that there is a really complex ecosystem that we're part of, that we have to not, mess up. And that we're already seeing the signs, and some people are already saying, we are in the beginning of the 6th mass extinction, and that, if we're looking at, for example, this kind of canary in the coal mine that is insect populations that are this, like, the base of the food chain and the base of so much kind of pollination and so on, that without this, without the flourishing of these parts of the ecosystem, other things are going to collapse, and it's really, really scary. But I suppose the point I'm trying to make is that, we have to not stick our head in the sand about this stuff as we have about carbon. And this is true for us in the built environment as well. And I would like to make sure that, as we talk more about carbon, that we are talking about the other impacts that the built environment is making as well, alongside all of these things. So I've just made a quick list, but yeah, to begin, I think it's the first most important thing is that we don't understand this as the built environment versus the natural environment, and that the best thing that we can do for nature is put a big keep out sign on it and make sure that, the built environment stays over there and there's some nature left for nature. I think that's a flawed understanding, and it also it lacks imagination. It lacks us being able to envisage a world, a future where we can have a positive and reciprocal relationship between sort of humans and the rest of nature. And that's a really important, I think, starting point, that we're part of this ecosystem, and we need to sort of respectfully and carefully lock into these cycles and not think of ourselves as separate, and that the best thing to do is to be separated. But yeah, so this is just a list of slides that I'm going through very quickly because of time limits, but of the ways in which the built environment and our professions, I suppose, encroach on ecosystems and damage ecosystems. So there's sort of the first list of the sort of maybe more direct ones. So we obviously encroach on wild habitat. We quite literally sort of curtail habitats that wild animals live on. And this is sort of true in sort of a very shocking sense that's shown here, but it's also true in lots of little ways to do with, when we redevelop even brownfield sites, that we are causing immediate kind of species loss, biodiversity loss, habitat loss, and that we're doing that in a direct way, in a really obvious way. We degrade water systems through creating unsustainable water demand and creating water demand in locations that can't service. And there is like a really sad series of streams that are completely sort of unique in the South UK and the northern France, of these habitats that are just completely unique in the world, that are being dried out and lost forever because of water demand, for example. And there's obviously water pollution. That's a very clear one, that we cause water pollution through and air pollution through our built environment activities. And there's the heat island effect that we all feel, as those of us that live in cities, but it's going to be so much more keenly felt as temperatures continue to rise. But then on top of those sort of more immediate and sort of effects that happen almost like within the site boundary, I suppose, there are also these effects that we're causing elsewhere. So in the same way that we talk about embodied carbon as being an effect that we're causing elsewhere, even though they're sort of from demand created within the site boundary, there are all these others. So things like ozone depletion, we have to not forget about this. This is something that we felt like we did a lot about kind of in the 80s and 90s, but this is still a problem, and especially when it comes to dealing with waste building materials and waste white goods and things like that. Acidification of sort of acid rain and of air and water and soil. This is still a huge issue, and I know that it's often kind of associated more with other industrial processes, but things like steel is a significant contributor through things like nitrogen oxides and sulfur dioxide that we emit into the air, and this causes sort of direct forest dieback and so on. And so we are, in the built environment industry, we are contributing to this as well. Another water one is eutrophication. So this is the sort of excess nutrients triggering this rapid algae growth that then just really disrupts the ecosystems. The sun isn't able to get beyond the algae into the deeper waters, and you get these kind of deoxygenated dead zones, and then also that algae can become toxic and cause red tides and so on. And this is something that's more associated with unsustainable agriculture and intensive farming and fertilizer runoff and things like that. But products like concrete manufacture also directly contribute to eutrophication. So again, we in the built environment are causing these kinds of problems as well. And then our material footprint, and this is something that I know Duncan talks about a lot in terms of moving towards a circular economy and reducing our overall material footprint. It's not enough for us to reduce the embodied carbon of our materials. We have to reduce the actual use of these materials as well. And it's not just about sort of avoiding waste, but it's avoiding that extraction in the first place, because if we continue to sort of create this demand for more and more and more materials, the effects of that on the landscape are really severe. And this is sort of one of many examples that we could use that show that kind of direct scarring. So this is red mud, which is this very, very alkaline byproduct of the aluminium industry that has to be kept separate from our other ecosystems. But of course, there are problems, and there are leaks, and there are ways in which this isn't always handled super well. And it's a striking example of the way in which the extractive architecture, if you like, is affecting the landscape. And so, this is so many different problems, and they're all interconnected in the way that the ecosystem is all interconnected. So we need to take a systems approach in order to sort of untangle this and to fit ourselves and our habitat creation into these systems. So this is a very crude diagram that I've drawn, but it's just trying to tie together some of the stuff that we're talking about at the moment. So I think we're all quite comfortable, and sort of not comfortable, but like we're familiar, and we agree now that it is unsustainable resource use and land use, that it is causing greenhouse gas emissions, that is causing climate breakdown and ecological breakdown. This is something that is happening. And thankfully, at least, a lot of climate denialism has been refuted now, and the misinformation is much less, and it's still some of a problem, but by and large we are now living in a world where this is acknowledged. So this is good. The COVID-19 pandemic is part of this, and I think at the beginning of the pandemic that was maybe something that was a little bit more fringe, but there have been lots of studies and articles and so on reporting on this now. But it's really important, I think, to understand that the pandemic is not a competing interest for climate breakdown or ecological breakdown, because it is part of it. It's part of the same human-made, is the same kind of human-made unsustainable behaviours and activities that have put pressures on our ecosystems in order to cause that. So just to be really clear about how that happens, so our demand for resources has caused and incentivized the invasion of wild landscapes. This has degraded ecosystems and caused habitat loss. And so then this habitat loss means that species are forced into smaller spaces, they're forced into new interactions that that sort of quite suddenly that they haven't necessarily been used to, and this creates a literally breeding ground, you know, that creates a really ripe environment for pathogens to jump from species to species, including humans. And we've been warned by scientists for a long time that we're making pandemics more and more and more and more and more and more likely. And this is sort of the first one that we've seen of this scale in this way, but this is something that we've been at risk of for a long time, and we will continue to be at risk of if we continue to sort of unsustainably use resources and land and change land use as we have been. And of course, our globalized society has distributed infectious diseases very well, and the real kind of kicker in a way is that it's really difficult to recover in this polluted environment. So I think it's really important that we recognize the pandemic as one of these things. And while that's sort of terrifying in some ways, maybe it's that there can be a positive of this, that it can maybe incite some action, incite some change. We've seen so much that, you know, change is possible. We've seen communities fight back, but we've also seen like incredible like inequalities, health inequalities been laid bare by this pandemic. So I think it's a really difficult thing to talk about, I know, but I think it's important that we bring it into this conversation when we're talking about ecological breakdown. And we see already immediately, you know, the pandemic is causing a recession, and as Scott also mentioned, you know, that the climate and ecological crises also cause economic harm and cause recession and cause, and the longer that we leave it, the greater that harm is. But this is where things start to become a little bit problematic, because then we end up in this position of economic instability, of sort of recession, of those kinds of economic problems. And so we try to grow our way out of it, to pursue that economic growth in order to rebuild, build back better, and all of those kinds of slogans that we hear. And what I kind of want to scream into my pillow about at night is that by doing that, all we're doing is redoubling down on exactly the same negative, well, it's a positive feedback loop, but it's a negative thing that is causing these problems again. And that we have to appreciate that if we just try to grow ourselves out of this problem, all we're doing is further incentivizing this unsustainable resource use and land use, and we're just doubling down on this problem. So we have to look at this. So I just want to dig into this a little bit right now. So as I'm saying, so the pursuit of economic growth is driving this ecological damage. So going back to that slide from the beginning, we can see that previously the argument was these things are really closely linked together, so we can't suddenly reduce our carbon dioxide emissions because we're going to harm the economy. And yet now we're saying it's a problem that these things are really, really linked together, because we want to be able to grow ourselves out of this recession and so on. So let's try to reverse this arrow by saying we don't actually have to have these things linked together. Now, this is just a sort of wish. There is no actual plan as to how we can do this. There is no evidence that this is in fact possible. In fact, this has been very strongly used the other way around, that this is evidence that we can't suddenly make changes because economic damage is going to happen. And I mean, just looking at it, yes, I drew these extension lines to make a point, but like it looks implausible. It's not just that we need to reduce our carbon dioxide or our emissions or our material footprint a bit, you know, relative to economic growth, global GDP growth, is that we need them to go in the absolute opposite direction, and yet at the same time still continue to grow the economy based on what? Like the economy is not dematerializing, the economy is rematerializing, even though over the last decades, whether you take a specific country or whether you take the whole global economy, the amount of economy that has become sort of tertiary sector or services or sort of weightless in terms of the internet and things like that, and that gives this impression that perhaps this is happening. It's not. Our material footprint has continued to grow despite that. But still, there's this idea like, oh, it's going to be fine. Technology is going to come along. And this is the exact same problem as we were talking about with the carbon capture and sequestration, is this idea that the technology is going to save us. And so just to take one example of around renewable energy. So, you know, we see graphs like this and it's like, it's brilliant. You know, we're getting more and more and more energy. It's sort of going up exponentially. It's going to be fine. But the problem is, if we continue to pursue that economic growth, then the overall energy use, so this is the total energy use and production from all sources, is also going up massively. And the goal that we're currently setting, renewable energy production, is not only to kind of meet our current energy needs, but actually to grow at such a supreme pace. And just to sort of make that point as to how big of a jump this has to make, these are those two graphs at the same scale. Like, it's tiny. Our renewable energy budget at the moment is about 5% of our total energy use. It's about the same amount of energy that we globally had in 1850. And so if we're going to make 100% of the energy that we use renewable, which is what we need to do, we need not only to massively scale up renewable energy use, we need to reuse less energy. We need to meet in the middle. We can't just expect that energy use to go. And that means that we have to stop growing the economy and stop requiring more materials, more energy, more production, more everything. We can't just have more. This is the point. And I don't know if I have time to describe this, but at the moment, this idea that we have, it's fine that we keep making things worse, because at some point we're going to reach this tipping point and we're going to suddenly start to make things better. And there's just no evidence that that is possible. It's just mad. And the evidence that you will see sometimes, and this is from like some UK government evidence showing that yes, we are starting to improve things. All that is doing is fiddling the books. It's just taking off, because we've moved a lot of our industry offshore. It's just taking all of that off the books. And that's the only way that they can make it stack up like that. If you actually look at what we consume, and so this is why I'm so excited about the way that we're talking about embodied carbon, and that what I would like us to be talking about embodied everything else, embodied water, embodied energy, embodied materials, material footprint, embodied noise, embodied social value, because that way of thinking about embodied impacts means that we can't do this, that we can't just take our impacts off the books if they don't happen to happen within our boundaries, and we continue to take responsibility for that. So that's really good. But yeah, so the point is, we can't keep increasing energy demand and resource use. We have to acknowledge that that growth is driving this, and instead we need to, I'm going to have to skip across this, I'm very sorry, it's too much. And we have to instead find an alternative way to equitably distribute our scarce resources and find alternative economic systems. And I'm just going to flash some up for you to Google later in case you're not familiar with them, but there are new economic systems and ideas, things coming out, things like sovereign money, which means that takes the power to create money away from banks and to democratically elected bodies such as governments. That they can be the ones to create money and therefore much more closely control the economy. There's things like modern monetary theory that understands tax not as something that is needed in order to fund public spending, and understands that that is a fallacy, and actually that taxes are about controlling inflation and controlling this distribution of resources and so on. And that, you know, if money is a construct, then money can be used in a much more careful way. And these kinds of economic theories allow us to escape the dependencies on ever increasing growth, which means that we can actually tackle our environmental problems. Lots of kind of corporate reform things are connected to this as well. So if you know things like sovereign money and modern monetary theory about the ways that governments could think differently, there are also different things around how, you know, us as corporations can think differently. So there's the certified B Corps, where you're considering not only your stakeholders and your profits, but also other stakeholders, such as your workers, the community that you have impact, the environment, and so on. There are policies such as rent controls or limits on advertising and things like that. And I think, you know, we will look back on some of the advertising that we see now, and it will be as shocking as this is to look at now when we talk about the kinds of incredibly environmentally damaging and high carbon goods that are still being advertised and still being driven forward now. And then there's lots of fantastic things to do with universal basic income, care incomes, training incomes, that can really help to, you know, in concert with these other economic policies and changes centrally, that can be there to support us and equitably distribute resources. And this kind of stuff will allow us to actually reduce working hours, to scale down our harmful industries, and to reduce our energy use. We will be able to do this if we start to have these kinds of economic policies under the current growth paradigm where we need to keep growing in order to solve our other problems, to do with like not tackling inequality head on, for example. We have to keep, it's very, very difficult. It's almost impossible, probably is impossible to reduce our environmental impacts. But with a combination of these new economic policies and direct action on social issues, we can then reduce our energy use, reduce our material footprint, reduce our emissions, and just be nice neighbours to each other. I'm going to finish there. Sorry, Duncan, I told you asked me to talk about too much in 20 minutes.
I think you did fine, but I've been writing down lots of questions again, and I'm sure we'll have others. But I think what we should do now is go straight into Elmer Demisovic's presentation. So Elmer's from 4D Architects, and we'll look at lots of case studies now.
Indeed, the topic is really very interesting and fascinating stuff we heard so far. I will probably now go further to some also practical issues that we as designers can tackle and take into account when working on projects. And as being designer and a scientist at the same time, obviously I've been wondering where things go wrong in construction and design, and how can we fix that. And I wanted to address today some 7 points which I identified as kind of key discussion points also through the design and the construction projects. And for 6 of them, I have developed some research teams in collaboration, a number of protocols which we used in some projects to test them that help us to speed up the conversation on circular design and sustainable building in general, and bring some more awareness on design tables, but also on tables of CEOs and owners of buildings and the construction companies. But first one, which is not so practical, it's really very much the awareness, which we always have to, the story we always have to bring up, and whether through presentations, talks like this, or real talks with the clients, trying to bring the discussion really and focus discussion on what are we talking about and what is the role of building and construction in all this mess that we are in at the moment. Because obviously we have really reached certain limits as a society, and the planet which we have inhabited, we do need to understand that. We do need to understand where are these limits, and start to move forward and start changing the systems that we have built up ourselves. Because the key challenges here are the systems that humankind has built itself. And that's also what I always try to show with this slide. Don't see it fully, but basically we are aware of exponential growth, population growth on the planet, which is directly related to the consumption of resources. And the World Bank produces every year, the world map indicating the status of the availability of resources per country. And the nice thing is what the World Bank does is they are creating this kind of footprint per country, indicating the resources that the country itself uses per year, and how much of these resources do they have are available within the borders of the country itself. The green color basically represents the countries which have more resources than they use per year. And the red color obviously represents countries which use more resources per year than they have at disposal within their own borders. And you can see on this slide the difference between 1961, there's the first map that was made, and 2012 or 15, the last one I have here, showing how the Earth is coming red. And the latest reports from the World Bank basically indicate that all these red countries are using 4 times more resources than they have at disposal. And the problem basically is, and the challenge is, that this fact of tripling the use of resources in the last decade or two, is related to the system that we have created ourselves, and it's a system of take, make, waste, which we call linear economy, and we still live in. And obviously, when coupling that kind of linear use of resources with the market economy, and market economy stimulates consumption, and the consumption means if you want to have a growth, but something we heard in the previous presentation, market economy is stimulating more consumption, and that means that products and use life of products is becoming much shorter, and that all brings us to the fact that we are using more and more resources and creating more and more waste and all negative impacts of that. So on the story of awareness building, it is obvious that we come to the kind of general conclusion that we have reached certain limits together as a community on this planet. We need to look for new system which will be more resilient for the future and future generations. And we come to the concept of circular economy, where waste would not exist anymore. In the world of circular economy, the rest materials from one system would be resources for the other one. And these feedback loops should be kind of positive feedback loops, should form the economy of the future. So there are kind of nice examples in the world where we see how this concept works, and obviously more and more people in industry are very much convinced that this kind of more positive approach and feedback loops are needed need to be embedded into our own system of use of resources. But there is still a lot of work to do, and especially when looking at the construction, the question is, where are we now with the construction and design of our buildings? How far are we from the ambitions of eliminating waste in construction and creating buildings and built environments which will merge with the natural environment and provide kind of more positive and not negative impacts on the natural habitat that we have as a people on this planet. So looking at the construction industry, obviously, we see that buildings are built in a way that when we want to change something or whatever with the building, the only way we can do it is by demolishing this. They are being demolished all the time, and mainly due to the degradation of materials, and there are new technologies, better isolation standards, inability to accommodate different use needs, no transformation capacity in buildings we design, inability to exchange building components and materials and so forth. And the fact that we deal with today when talking about construction industry worldwide is that it is the major industry, one of the key industries that will play an important role when fighting climate change and our path towards a circular economy. With its very bad negative impacts, as 40% of CO2 emissions related to this industry, 50% of material resources going into this industry, and 50% of national waste production related to this industry. So this is the environment we are dealing in. And as I mentioned, as a designer and a scientist, I'm trying to understand where things go wrong and how can we fix it. And this is also, this is my last slide on the awareness building story, but it presents very much our attitude to the construction and how we value the construction. We see this kind of demolition scenes in our cities all the time. I live in Amsterdam, and this is the project I followed because it's nearby, and the Fortis Bank in the city center, which was 16 years old, with a granite facade, which you can still see in Cheops Pyramid in Cairo, which stands there for 3,000 years, has been crashed into pieces after 16 years and became maybe part of the sub-construction for the road in the Netherlands. So a building which was there in the city center lost its use value, material value within 16 years and gave way to new construction, which has been built in the same way and probably will be demolished if you see the trends after 25 years ago. Again, so the problem I see in the construction and the design is that we perceive buildings as a static product, static structures, which do not change, while the key core question that architecture has to answer and building has to answer and provide is to provide a shelter to human activities and human life. And that core that the building and construction has to answer this human activities and life is very dynamic. So obviously there is a fundamental fault in the way how we approach design and construction in general, building kind of pyramids around something which changes so often. And this slide just indicates how dynamic our own lives are. We go through 7 phases in our life, and every phase of our life requires something else from our built environment. In the Netherlands, we have the situation that people are moving like every 7 years from one house to another because the house itself cannot accommodate the requirements of the next life cycle. But that's kind of a crash that happens when we look at the buildings that we inherited, that we built and even designed today, and that are not built to be adapted, to be transformed, to be upgraded to something else. Its parts are not designed to be recovered, also updated or upgraded with some new technologies and brought back into these buildings. But we know only one thing: we design buildings for only one end of life, and that's demolition, and that creates huge negative effects on built environment in general. So the future, as I see it, and all the tools and protocols I developed so far, also within European projects, is developing new transformable buildings, upgradable built environment, which does not recognize demolition as a process at all, but reconfiguration, reconstruction, transformation, and so forth. That building can live and change and adapt through the whole life cycle without being demolished but upgraded. So where do we start if we want to approach the building in the future in such a way? And if you want to have design buildings which will not end in 20 years because they cannot be adapted to new user requirements, but therefore needs to be demolished. We start with understanding and the question properly, and also having a good discussion with the owners of the future buildings. And this is the project I'm showing here, done with the Housing Corporation in the Woonplaats in Enschede, in the eastern part of the Netherlands, which wanted to build kind of few housing blocks in one of the neighborhoods in Enschede. My question at that point, as we have already raised the issue of problems that we have with existing buildings, the demolition and all negative effects coming from the demolition, I asked them to think twice before presenting their design brief, before presenting their user requirements for their houses. And I asked them also to look and do some study themselves about the demographic changes in the following 50 years and the developments of the city and the neighborhood. And based on that to sketch 4 to 5 user profiles that they expect to have in these buildings in the coming 50 years. And surprisingly, I have to say that the Housing Corporation took it seriously and came up with 5 use scenarios, or 5 types of apartments that they see being used in coming 5 years based on the demographic changes of the city itself. And this was kind of input to then develop a system, design a system that will be able to accommodate these changes from one to another or fifth without demolishing, but is allowing the block to live together with its users and the future users, and to accommodate their future needs without being demolished. And already in this project, the ideas of understanding the transformation capacity of a building design, what it offers and can offer for the future users, came on table. A model which I developed later, and also within BAM project, is transformation capacity tool, which addresses this issue, and I will talk about that a little bit later. The other important thing, besides understanding the future users and potential users and user requirements, and try this not to design building for one use, but for multiple users, which requires absolutely more action from the and responsibility from the owners of the buildings themselves. The other one is the technical requirements. As I mentioned, sometimes we deal with some new regulations like better isolation, better materials, and so forth. And that again can cause is the reason why we demolish buildings. So why not design building component systems and parts, which are again upgradable on the level of module systems and components, so that you can upgrade and reconfigure your system. Like if I say, this is the development we've done with the consortium of industry partners in the Netherlands, and the Housing Corporation was involved in here as well, where you can have a variation of energy performance requirements built into the module itself, and the module can also be adapted depending on the orientation where it's formed. Is it south or north? Do you need solar panels or not? More open glass or not, or even bigger spaces. So if some additional changes are done on such a module, then it's being brought back to the factory, the reconfiguration takes place, and the module goes back with the new functionalities. And that's the upgrading part of that. But also on other systems, I'm just showing very shortly a few of the systems that we've been developing, different consortiums, always with the industry and one of the potential owners, in this case, the nursing home in Hengelo. Is also understanding the potential patient profiles, for example, in nursing homes, or potential of transforming the nursing home into a housing typology of bathrooms, and then designing a system for bathroom around that, so that it can be transformed again and upgraded without being demolished. So those are already 3 points which I found in the last 10, 20 years important to discuss when working on the design of buildings and talking with the owners and the clients, but also with industry, trying to understand how do we make this shift towards other way of building, towards the other perception on what building is and its performance is, and moving away from from static to dynamic structures and systems. Another quite important point is also the legislation and building codes. And that's something where we work a lot these days on. And this is the timeline of a development of building codes in the Netherlands, where we can see that every time a new regulation came in, boosted the improvement in quality, in isolation quality, acoustics, and so forth. There's a number of codes were directly related to the improvement of quality of building. At this moment, we have the final code on thermal regulation, which is a zero energy building. That means that this whole process after oil crisis in 1973, when the focus also in building regulation was very much on the energy, is now ending more or less and moving into next phase, which will be dealing with circularity of resources and materials in a building. So we can expect to get now a kind of row of these new building codes and regulations which will be addressing this issue. One of the things, for example, when talking about the building codes and which parts could help us to make a step further to designing these building structures which will not be demolished after their first use, but will have a capacity to accommodate another use, is simple. For example, a load of the floor. The fixed load, for example, for the housing is 1.5 kilonewton, for offices 2, or for nursing homes or some hospitals 3, and so forth. And what happens now is that if we have a housing block and we want to transform it into an office block, it is not possible simply because the load-bearing structure is designed with minimum capacity and cannot carry this loads. So that's kind of one of the straightforward things that definitely extend further the use options of buildings, or the brutto floor-to-ceiling height. And those are the indicators which are already coming from this transformation capacity tool, which I will show in next slides. But floor-to-ceiling height, if it's on a minimum height, like 260 now in the Netherlands for housing, and everyone sticks to a minimum, when transforming it into something else which needs more installation services and so forth, will cause a problem. So there are a number of issues that we have recognized already, which can extend the use of building in the future if we take them into account in the beginning of a design phase. And many of these indicators I did integrate into a transformation capacity tool, which is assessing the ability of building to transform from one function to use to another, taking into account some spatial indicators of the building block and spaces, and the technical capacities within of the building. This tool is also developed as a part of Revit, or plugin for Revit. So for the designers who are capable or are using Revit in early design phases, they do get kind of direct feedback through the different design stages on the transformation capacity score, and can improve it through the design process. Not many designers do that at the moment, and that's also the reason why this tool is now being used also, and this is an example of that for the new design of a new hospital in Brussels. It has been used to test the design solutions after 2 design phases, like the preliminary design phase and the definitive design phase. And after 2 of these sessions and improvements with the design and engineering team of the hospital building, they came up to increasing a few aspects that ended in increased transformation capacity index. And that meant basically 0.77 meant that the hospital can be transformed by partial demolition, which would not include more than 10% of demolition of the structure. So that's these kind of tools are helping us in a design process to understand the impact of our design solutions on the future use and potential transformation of buildings. Another tool I've been working on is the tool which is supporting the construction companies when trying to understand how to deconstruct existing buildings in a best way and recover materials for their highest value. And for that, I developed a reuse potential tool, which has been formalized also within BUMP project. And now we are integrating that tool with the digitalizing, actually, in a way that we have scanned the municipality building in the Netherlands, 10th floor high building with the infrared scans and just normal scans from inside and outside, and created kind of basic reversible BIM, which then uses the transformation reuse potential tool, which measures how easy it is to take to recover element out of the building without damaging element itself or surrounding elements. And that assessment is being done manually on a building level, on a system level, so how easy it is to take facade system out or part of the facade system, and on a component level. These evaluations are going on take some time, and that's why we have integrated it now with the BIM, which helps us to automatically create color coding system in Revit with plugin, and it indicates also the elements which at this stage have like up to 3 relations are green, up to 7 are yellow, more than 7 are red. And that's first indication of how easy it is to take something out, and the connections and other indicators from reuse potential are now being integrated into that. And obviously, this kind of information is helping the construction companies to understand better how to organize the construction strategy, and also what the reuse options of materials in a building are, which again help the owners of the building to understand whether there is additional value that can be taken out of the existing building. And finally, as a 7th point, I just want to point out that knowledge sharing is an important one, and therefore we are now developing with the Ministry of Internal Affairs in the Netherlands a knowledge bank for circular buildings, where we will put in the information which we came across and have developed within the different European projects on guidelines and protocols, measuring circularity, number of tools. We will also integrate realized projects, pilots in Europe, and there is an ongoing transformation lab, GTB lab, Laboratory for Green Transformer Building, which is being transformed once a year, and all results from these transformations will be put into that knowledge bank as well. So I hope I stayed in within the time frame.
You were fine, Elmer. Thank you very much.
Usually an issue.
No, it's been fine. I haven't seen any questions from the audience, unless I'm missing something. So I just I wondered if Maria and Scott could join us in as much as if they could turn on their cameras so we can see you. Just the three of you, that was fantastic. I mean, yeah, you could have all done 45 minutes each. But I wouldn't mind asking a question of Scott first of all. You're engaging with students and practitioners in quite a big way around these issues. I mean, who isn't scared of what you and Maria and Elmer and we're all talking about at the moment? So, and what do you think is the biggest challenge we face? It's a bit of a corny question, perhaps, but I don't meet many people that don't understand how terrifying a lot of these statistics and issues are.
I think probably one of the biggest issues is communication, because I've met people in so many other spaces, kind of in activism, and the built environment's not on the radar. Greenpeace, the WWF, Friends of the Earth, they don't talk about the impacts of the built environment beyond energy, and it's really getting that into any form of political discussion as well, because until it's there, legislation won't change fast enough. So it's probably communication with general public, and then communication with kind of political systems as well.
Well, you made that point that was it only 64% of the public knew what net zero carbon was?
Yeah, so 64% of people didn't know what it was, never heard of it, and 62% of changes in the UK to get to net zero are behavioural and societal. So we've got this huge disparity, even though most of the changes aren't technological at all.
So, Maria, you work for quite a large consultancy. I mean, do you bump into climate deniers all the time? I mean,
I haven't met any climate deniers in a while, but maybe it's the circles I move in. I think, yeah, I mean, we recently did a survey of our company, actually, and it was really interesting to see that like over 90% of our staff believe that sustainability is absolutely critical to our, environmental sustainability concerns are absolutely critical to Bureau Happel's future, and especially like the younger members really, like kind of clued in. But I mean, I guess this is a bunch of engineers, so it's a slightly.
Did you do a survey of your clients? Did you?
I mean, even like, I think obviously there's a huge spectrum, and some clients are really, like some of the stuff that we're seeing Lend-Lease doing at the moment is really exciting in terms of sort of talking about absolute zero carbon by 2040 and, working to science-based targets, 1.5 degrees and things like that, and trying to really push that. And other clients are not seeing themselves as kind of in a leadership role and sort of more come to us for sort of help with compliance end. But we do find, that more often than not, if you raise the subject in a kind of an open way, that you will start to have a good conversation. I mean, we had a workshop about with a client who hadn't, I think, ever thought about or heard of the circular economy before a couple of weeks ago. And by the end of the workshop, he was like, "Oh, yeah, I mean, this is good design. Yeah, brilliant," And he was like really converted by the end of it, and it was really nice. But I guess it's just we have to like approach this with a kind of open mind and giving people the benefit of the doubt. And like quite often, even though maybe it's not something that's familiar to a lot of people, I think there's generally like a willingness to understand, so long as it's not presented in a like a confrontational way, or in a like, this is really complicated and you need super expert consultants kind of way, things like that. There's a way of opening up a conversation that I think is more successful.
But you talk a lot about economics, and so you presenting that angle to your clients. I mean, I wrote down the market economy will kill us, basically. I mean, that's what you're saying.
No, markets aren't bad. Trade isn't bad. Capitalism is the problem. But specifically, like, we talk about growth because there's lots of aspects of trade and markets and economy. We can have a good, thriving economy. We can have markets. We can have. It's not that I hate money, or that is an inherent problem. It's this reliance on the growth of the economy that is the problem. And many people, businesses, clients and so on that we work with don't even have that business model. So long as you're not working on a business model that requires you to kind of double in size every couple of years, if you're basically working on, well, I just need to make sure that we all have enough money that we can sort of pay ourselves and we don't need to keep growing, then your business model in a stable kind of reciprocal economy probably, we'll be doing different buildings and so on, but the business model isn't radically different. So there's plenty of like hope and shared understanding there.
And it looks like with Elmer, you're providing many of the tools we need to really unpick a lot of the sort of testing problems, the realities of how do you deconstruct a building. And I mean, you seem to think that, and I agree with this, I have to say, but regulations are the big deal. That graph you showed the impact of positive regulations. From your point of view, what needs to happen next in the construction industry to make a big impact from the point of view of regulations?
Actually, I think there's something more important that has to happen in construction industry, I think now, is that I'm involved with many construction companies, and in the Netherlands, of course, it's kind of daily discussion on how do you reuse and what is the value of it, and so forth and so forth. But I noticed that most of this discussion is really very much on how do I reuse this window and put it into another building and so forth. And my point is, I'm saying that is not circular economy. That's not those are not the feedback loops that we want to bring into our system. We need to develop new infrastructure that will support circular economy. We need to go to the industrialized, bring in industrialized way of construction in full discussion with circular economy and reuse. And I'm now in discussion with one of the provinces in the Netherlands, where we have mapped.
Sorry, my event's overrunning. I didn't realise we only had it till 4.
We have mapped the future deconstruction projects or demolition projects. Let's call them deconstruction projects. Thousands of housing which will be demolished in coming, I think, 15 years. My suggestion there is let's try to build up refurbishment hubs and start building up really infrastructure that will support transformation of tons of materials from these buildings in industrial standardized way into new materials for the new buildings. And then the building coding and legislation will follow and help us to finalize that. But I think that the discussion is now still on the wrong in the wrong place. We have to think how to scale it up. We need to standardize, industrialize, and bring a real industry into the discussion of circular economy and start building up new infrastructure. We need to build up infrastructure that will support transition to a new way of buildings, and that's lacking.
And I guess we also need to retrain people. We need to increase the level of knowledge and skills to support this new way of working.
That's true, but on the other hand, I've done lots of studies on the quality of existing buildings and built environment. I have a problem with the buildings that we have built in the last hundreds of years, not hundreds, but last like 90 years. Because we see that most of these buildings, and very often in my discussions with housing corporations, we all agree that like 40% of housing stock can be demolished tomorrow because it has really a low value. So my problem is not only with such a big focus on existing buildings, of course, we have to sort this issue, how to deconstruct in a good way. But my problem is that we are designing buildings today using the same mistake and creating the same mistakes that we will deal with the same issue in 10 or 15 years again. And that we need to start changing the design culture, the construction culture, and think about really how do we build a new building which will not cause us all these problems that we are dealing with now. So that's missing again. Yeah.
So then I can bring Scott into the conversation then, because Scott, you must be thinking about how do we train architects and engineers to design buildings in a different way. I mean, how profound a problem is that, do you think?
I think in quite a lot of it, I found that when...
Oh, we've lost you. Can't hear you.
Is that better now?
Yeah.
Is that back up? Right, there we go. Yeah, there is such a huge gap, and the people doing the educating were educated to teach buildings to cause problems because they weren't addressing climate change when they were taught. So we've got this kind of really, really negative feedback loop of the people doing the educating of future practitioners might not have these skills themselves. So if we're going to be doing upskilling, it's not just an industry, it's immediately an education, because there is this, even in speaking to tutors and educators and asking what do you lack or what do you think you need to know, sometimes it's just that I have no idea, or I've never really heard much about things like the circular economy has now become a buzzword, and it's just jumping around in quite a lot of spaces without people really understanding about deconstructing buildings. And that kind of, I really like the term the transformational capacity of a building, because that's instantly a game changer in the culture. If you're teaching people to design with that always in mind, that's flipped the game entirely. But if we've got people being taught today in a university class and they're being taught to design buildings that have a 10 to 15 year lifespan maximum, then we're just going to keep on churning out a skills gap, and we're going to make that bigger and bigger. So I think it's kind of bringing people doing like research on the kind of cutting edge that Elma and Maria are into schools of architecture, into offices to do that and to have those conversations, because Yeah, it's also encouraging people to do this training themselves, and getting architects to admit they don't know something is hellishly difficult. It's not fun. Once they do, it's fine, but getting any architect to say, I don't know this, is quite hard.
Well, Maria, yeah. Go on,
I just wanted to add on what Scott said. Usually we have discussions in the Netherlands when we talk about construction industry, everyone would say that's the most conservative industry and so forth. I've been working at universities as well, and I know how difficult, I understand absolutely what Scott was talking about. And actually my impression is that universities are not lagging behind the construction industry, and probably it's inherent on the human nature. I mean, we as humans, we create systems and institutions, and we don't like changes. And therefore, it doesn't matter whether we talk about education or industry, it's difficult to change. So we have to find a small path through to trigger the change.
What I've noticed, obviously, is both Maria and you, Elmer. You've both got a number of hats. I mean, Maria, I've forgotten how many different qualifications you've got, but you do have a foot in an engineering cap as well as architecture. Am I correct?
Yeah. I got an engineering degree as well, and actually I heard it described by somebody else really nicely, like not about me, about themselves, that they were undisciplined. And so I've decided that I'm going to wear that with pride now. And I mean, I think a big part of the problem is that we don't necessarily step out of our own kind of scopes enough, and don't, like Scott's saying, it's very difficult to get people sometimes to admit that they don't know about something, and therefore they kind of retreat into the areas that they feel really, really secure. But that means that we don't think in a systemic and cohesive way. You know, if we wouldn't be in this mess, arguably, if economists and ecologists had to talk to each other. And, you know, the incredible divide between what we think of as regeneration and what we think of as regenerative design, even though they're practically the same word. You know, it's just like there are so many weird divides that I think that we can break down some of those barriers by stepping on each other's professional toes a little bit more. And then it's really nice to, I mean, it is like quite scary sometimes because I was working in architecture, and then I was working sort of across architecture and engineering. And now that I'm at Bureau Happold, I'm sort of more completely surrounded by engineers, which is very comforting, but also it's a world where, you know, there's lots and lots of people who have incredible niche knowledge in lots of different areas. And we all have to appreciate that, like, I don't know loads about what, you know, Trevor does, but that's fine because Trevor knows, and we can have a conversation, and we know enough that we can talk to each other, and Trevor knows enough that he can talk, you know, and so on. And so that kind of networked knowledge, I think, is part of the answer, but it means that you have to constantly be in a place where you're comfortable knowing that you're asking other people that you don't know, and that's not something to be ashamed of, and that's not something to sort of squirm at and retreat from, but rather a good and exciting thing. But it's a really different mindset.
Yeah. Okay, I'm gonna ask one last question, and I mean, I think there's no doubt that things are pretty scary out there, but things are changing. There's a lot of positivity out there. I just think what I want to ask you all to consider is what's the next big thing we need to focus on to affect change? I mean, I thought Elmer was going to say it was legislation, but maybe it's not. What is the big game changer that we need to sort of focus our energies on at the moment? Because the problems are coming at sort of 360 degrees at the moment. They all might be because of our behavior. But yeah, go on, Elmer. Answer my question.
I think we can't afford ourselves to work in sequential order anymore, and we need to tackle all the issues in parallel. Because I want to say, and education and industry and legislation and so forth and so forth. Yeah.
Thank you, Elmer. Maria?
Yeah, no, I mean, I agree with that. And we have to push forward on all fronts together and at the same time. And I think every individual can look at, you know, ask yourself, you know, where do I have agency? Where can I affect change? And just whatever that is, do that, because all of it's helpful, all of it's moving, you know, assuming you're working, you know, in the same direction. But like, we have to do everything at once, and whatever position you're in, there's definitely positive change that you can make, and that I think can be quite empowering. And just, yeah, we have to just do it all together and just keep talking to each other as well.
And Scott?
Yeah, I think it's blending just both of those. It's looking at things as in systems and where can you have the most impact of what you do. And that's a huge thing. It's not just accepting, I do this one job, I do this one thing. You might be fantastic at something else. Some people are good at communicating, some are really good at design, some people have a really good understanding of how nature works in regards to buildings, and really giving people the kind of spaces to have the open conversations, and also just kind of enjoy doing the work as well, because if we're not enjoying it, if it's not imaginative and it's not fun, it's going to be quite hard. But if you can let people use their imaginations more and kind of imagine what it would be like if we actually did it, not just all of this, what if everything goes to shit, what if things get better, what if we're hitting net zero by 2040, not 2050, like start asking questions like that. Just kind of ask more what if questions. They're always more fun.
You want to say something else, Elmer?
I just wanted to say that, like, when looking how really extremely slow the politicians act, we now have to force them to bring in the legislations. And of course, from economic point of view, you would get the best benefits if we could put some legislation in place that will force industries to make swift decisions, set up new infrastructures, and so forth. But we, in discussions I had so far, I don't see political powers now that are willing to, they don't dare to. So their answer is always the market should solve it themselves. Of course, this is not a market issue, this is societal issue. So it is really going back to the parliaments and everywhere, but we have to link that to their tables as well by forcing everything.
Okay, one thing I would add, I think Maria should be president of the RIBA. Scott, I think there's a job going at the AA. I think you've got to be put up in a prominent position. And Elmer, well, you're up there already, so that's great. I'd like to say thank you to our three amazing speakers. You've inspired me, and it was a great session. Thank you very much from the virtual world.
Thank you for hosting it. And thanks
Thank
for
you,
the praise as well.
Thank you.
His praise to there.
Yeah, I'm just going to pop back in just to say thank you to you, Duncan, as well. Great moderation and great chairing, and I appreciate all the time and effort and energy that went in from all of our speakers on this panel and throughout the day. Last thing for me to just finish the session with is the networking, the expo area, the rest of the people that are still engaged with the sessions. You can still reach out to them, send them a message, ask them questions. Anything that didn't get answered from the chats, I'll put to the various speakers that it was addressed to, and they'll come back to you in time. And just lastly, to say thank you for joining. This network that we're building around WasteBuild is there for people to share ideas and to come together and to contribute to those to some of these solutions that we talked about. So keep an eye on WasteBuild 365. The next one's coming up on the 19th of November. Keep an eye on the website, wastebuild.com. And I look forward to speaking to you all again. So thanks once again, and speak to you soon. Bye-bye.
Bye, everybody.
Bye.
Bye.